Hi, I'm Jeff Davis, and this is a What's New in Anthos video brought to you by ROI Training. Today we're going to look at the revamped process for deploying and managing Anthos clusters in AWS. So if you've worked with Anthos on AWS clusters in the past, you're familiar with the clunky installation process. You had to create YAML configuration files, you had to use multiple different utilities to create a bastion host in AWS, to create a management service host in AWS, to create your user clusters, and so forth. So Google has re-engineered the entire process and made it vastly easier and clearer to go through. So let's switch over to the demo environment and see how it works. Let's start by looking at the online documentation. There's lots of good stuff here that lays out what we need to do and how to do it. Before we can actually deploy an Anthos on AWS cluster, we have to make sure that both the Google Cloud and the Anthos environment, the AWS environments are set up and ready to go. So there's a set of prerequisites here, and we're going to look at each of these articles quickly. We're going to see what you're supposed to do. We're going to see how you do it, and I'm going to show you that I've already done it in preparation for this demo. So the first thing is we're going to set up our Google Cloud SDK. We're going to make sure that our command line utilities are configured, and we're going to make sure that the necessary APIs are enabled. So if you look at the documentation, they basically tell you this is how you authenticate your SDK. These are the services that you need to turn on. The only new service here for our purposes is the multi-cloud API service. So to make sure that this is all ready to go, what I'm going to do is go to my local terminal running on my computer, and I'm going to run a gcloud command, gcloud cloud shell ssh authorize session. What this does is actually starts a Cloud Shell VM in Google Cloud, and that has all of the utilities installed and so forth. And I am going to SSH into that. So I'm working on my local computer, but the commands are actually executing on a Cloud Shell VM in the cloud. Now, what I want to do is I want to set the default project that I'm working with so that if I'm creating GCP resources, this knows where to put them. So I'm using a demos project for that. And then I also want to set the SDK so that when I create AWS Anthos resources, so there are GCP resources that represent the Anthos stuff that's running in AWS, I want to specify where those GCP resources representing AWS stuff, where those resources are created. And that's going to be in the US West 1 region. I also want to make sure that the multi-cluster cloud API is enabled so I can actually go to this page and I can see that the API is enabled. It's not enabled by default. You would have to turn this on. Now, the next thing that you do after making sure that the gcloud command line is set up is you want to make sure that you've got your AWS command line interface tools installed and configured. So I'm going to go back here and I'm going to actually install the AWS command line utility. I've got a bash alias here that automatically installs it in the Cloud Shell VM. So this will take a moment, and when it's done, I should be able to run the AWS command and use that to interact with the AWS APIs to create and manage resources in AWS. So for example, if I type in AWS here, you can see that it's now installed. The next thing that we need to do is we need to set up the network onto which we are going to deploy our cluster. And you can see here, they give you like an example architecture. So we have a single VPC with a /16 CIDR block. We have multiple different subnets. We've got some subnets that are private subnets. This is machines that don't get public-facing IP addresses, and then we've got a set of subnets that are public subnets with recommended IP address ranges, and so forth. So this is what we're going to shoot for. This is not always the architecture, but this is a good reference architecture. And then they actually give you each of the command line commands that you're going to use to actually create, in this case, the VPC, and then configure DNS on the VPC, and then create the subnets. These are the private subnets, and then these are the public subnets, and so forth. So you would simply Copy and paste those commands with the appropriate variables replaced with your values. If we go into the AWS console, you can see that I've actually got 1, 2, 3 private subnets. I've got 1, 2, 3 public subnets. You can see that these are all on a VPC network called Anthos AWS. You can also see that there are route tables that are set up. So I've got AMC routes, and this is controlling the flow of traffic between subnets and out through the internet gateway. I have an internet gateway that is configured for my VPC network. I also have NAT gateways that are configured for each of the public subnets. All of this was done for me by simply copying and pasting those commands from the documentation. You also need to use an AWS encryption key to encrypt etcd data and data on the individual nodes. You can create 2 keys or just 1. Again, they give you the command line command to create a key using Amazon's key management service. So if I look in my key management console, you can see that I've created 1 key that I'm going to use for both encryption activities. And then we need to set up a bunch of permissions. So we need to set up an AWS role that will be used by the multi-cloud API in Google Cloud to send commands to AWS. So we have to create a role, then we have to create a policy that is going to be associated with the role. Then we actually have to attach the policy to the role. Then you're going to create another role for control planes. These are the control plane VMs. So you're going to create a role, you're going to create a policy, you're going to assign the policy to the role, and then you're also going to create an instance profile for the control plane EC2 instances. And then you're going to go through the process once again for node pool nodes. This is the role, this is the policy, this is the attaching the policy to the role, and this is creating the instance profile. So if we go to the management console, you can see that there's my API role, there's my control plane role, there's my node pool role. And if you look at policies, you can see that there's my API policy, my control plane policy, and my node pool policy. Then the last thing that you're going to do is you're going to create an SSH key pair that you can use when you create your EC2 VMs, and you can use this key pair to authenticate and do SSH administration against those. Okay, so we've got everything set up. Now it's actually time to build a cluster. So I'm just going to work off of the quick start documentation. There's more detailed documentation down here. But what we're going to do is run a command. This is what the command looks like. And we're going to run this command in our Cloud Shell session, and it's going to create the control plane for our cluster in AWS. So I'm going to switch back to this page, and I am going to select, copy and paste this command, and we're going to run it. And while it's running in the background, I'll sort of break it down. If you look in the documentation, it has a description for what each of these values are or is. You can see that we're creating a cluster. My cluster is going to be named something different, but you have a cluster name, you have the version of Anthos that you're installing, you have the AWS region into which you are placing your EC2 instances. You have the fleet project. So this is the GCP project where you register all of the Anthos clusters that you want to manage as one fleet. So this is how you do configuration management, policy enforcement, stuff like that. You're going to specify the VPC onto which you are deploying your control plane instances. You're going to specify the subnets, and I'm actually going to deploy one control plane instance each into 3 different availability zones for fault tolerance. You specify the CIDR block of IP addresses that will be assigned to pods running on your cluster. You assign a CIDR block for the service IP addresses on your cluster. You specify the role that will be used by the control plane nodes. You specify the instance profile that will be used by them, You specify the 2 encryption keys, and then we've got some tags here, which is just metadata that helps us identify the role of these instances in our cluster. So if we switch back here, this takes a little while to run. So what we're going to do is we're going to pause the video here, and then we'll jump forward to when this is finished. Okay, the command has completed. Let's do a quick check in the AWS console. And what we should see is there are actually now 3 EC2 instances. These are the 3 control plane nodes that have been created and are running in 3 different availability zones. So the good news is we have our control plane up and running. Now what we need to do is we need to actually create a node pool. So if you scroll down a little bit, Google again gives you the command for the node pool. What I'm going to do is I've got a version that is prepared for our demo. I'll run that, and then we'll take a quick look at what the various properties mean. So again, you're going to create a node pool with a given pool name. You're going to specify the cluster on which the node pool should exist. You're going to set the node version. Notice that you've got min nodes and max nodes. So what we're going to have is an auto-scaling cluster. It'll automatically add or remove nodes as necessary based on if you're trying to deploy more pods than will fit. You can specify the maximum number of pods that are allowed to run on a particular node, the root volume size, the subnet ID where the nodes for this node pool go. So all of the nodes for a particular node pool will end up in the same subnet. If you want multiple nodes and multiple subnets, you would create multiple node pools. Again, you're going to specify the instance profile that's going to be used by the node instances. You're going to specify the encryption key, the SSH key, and some tagging metadata. And this will take a little bit of time to run. So again, what we're going to do now is we're going to jump ahead to the point where it is complete, and then we will take a look at the results. All right, we have success. Let's switch back and look at our EC2 instances. And what we should see, if I refresh this, is we now have 6 instances. So my configuration had 3 control plane nodes and a minimum of 3 worker nodes. So I've got 6 VMs here, okay? These VMs are still, it looks like, initializing, but they're going to be ready to go in just a moment. So let's actually try to use this now as a Kubernetes cluster. What I'm going to do is I am going to update my kubeconfig file with a context that points to this newly generated cluster. So I'm going to use gcloud container AWS clusters get credentials and the name of the cluster. And this says a new kubeconfig entry has been created. If I use kube context to see, I can see it's got a big long name. I'm going to rename this just for simplicity's sake. So I'm going to do AWS equals that. And so now my context is named AWS. And I can do k get nodes. Again, I've got bash aliases. So k equals kube control, kc equals kube context. So if I do k get nodes, what this should show me is the 3 worker nodes that are available to me in my cluster. Ta-da! There we go. Now, you may not have noticed, but there's something really interesting going on here. Remember that my control plane nodes don't have public IP addresses. So you might ask yourself, how does kube control running on this VM in Google Cloud, which is outside AWS, how can it send commands to the API server on the control plane instances in AWS? Well, what Google has done is automatically configured something called the Connect Gateway service. So there's an article here. You can look online at the documentation that explains how the Connect Gateway works. But essentially what happens is this. You configure kube control to talk to the gateway service running in GCP. GCP acts as a proxy. It receives your incoming requests, and then it actually sends the requests over an encrypted channel to the API server running in AWS. The control plane nodes in AWS create an encrypted channel. They go through the NAT gateway. They talk to the service running in GCP. So your control plane nodes are talking to GCP and kube control is talking to GCP. And all of your commands pass through this service, which means you don't have to create a bastion host in AWS. You don't have to VPN into the VPC network and so forth. If we were to actually take a look at the kube config file, so if I do nano .cube/config, what I should see here is that the server, it's not actually pointing directly to a control plane node. It's pointing to this API endpoint in Google Cloud. So all of my commands go here, and then it sends those on in the context of a security account that it has configured. And this is all done automatically for me. Now, this makes it a lot easier to immediately start working with your Anthos cluster on AWS. That said, there are some commands like exec and proxy that don't work using the gateway service. For those, you would have to set up a bastion host or you'd have to VPN into the AWS VPC. So we have the cluster up and running. We can use kube control to manage it. Let's actually take a look at the graphic interface in the Google Cloud Console for managing our AWS resources. If I click refresh here, what we should see is that there's an entry now in our GKE console that points to our Anthos cluster running on AWS. But you'll notice that I can't actually use this to get any information or do anything. In order for this user interface to manage the remote cluster, you, as the logged in user, have to configure the console with some credentials that the remote cluster will recognize. And then when you issue a command in the GUI will send the command using those credentials to the remote machine. We haven't set the console up to do this yet. So the way that we're going to do this is we are going to first create a Kubernetes service account on the cluster. And then we are going to create a cluster role binding that gives that administrative service account administrative permissions. And then what we're going to do is extract an authentication token that we can use to actually log in the context of that service account. So I'm going to copy this, and then I'm going to switch back to the graphic interface, and I'm going to choose to log in. And there are multiple ways that you can log in. We're going to use this Kubernetes service account token. And once I've provided the token, now I, as a user working with this console, the console can log in as the service account on the remote machine. Once I've done that, then I can see details about my Anthos on AWS cluster. I can see the nodes. I can look and see what workloads are running. So you'll notice there's some agents that are running on the cluster, which are shipping data back to Google Cloud. This is a logging agent. This is a monitoring agent. I can look at all of the stuff that's running on the cluster and so forth. So I now have a command line tool for managing the cluster, standard Kubernetes management, and I have the Google Cloud Console, which allows me to manage the cluster. So now let's actually try deploying something to the cluster. So what I'm going to do here is I'm going to do just a standard Kubernetes deployment. All right, so I'm going to create a deployment called Hello Server. It's going to use a very basic application. Once that's done, I can look and see that the pods are actually being created on the cluster. I can switch back over to the graphic interface and look at workloads. And what we should see here is that there's a new Hello Server deployment. And again, the graphic interface will tell me like what managed pods there are for that managed pod. It will tell me what node it's running on, what containers it's running, stuff like that. And then what I want to do is I actually want to expose the service as well. So let's switch back to here. And I'm going to copy and paste this command. Now I want this service to actually be exposed to clients running outside of the Kubernetes cluster, so I'm going to create a load balancer service. And this is going to automatically generate an AWS load balancer for us. So if I do get services, we should see that I've got the Kubernetes API server service, And I've got my new Hello Server service, which is a load balancer service that points to this DNS name. This DNS name is associated with an elastic load balancer in AWS. So actually, let's go to AWS. Let's look under instances. Let's scroll down here to load balancing. What we should see, if I do a refresh, is, hold on for a second. There are two load balancers. This load balancer is a load balancer that sits in front of the control plane nodes. So this is for access to the API server. This load balancer was just automatically created for us, and this is the load balancer that receives incoming requests for our application. So what we want to do now is we want to look in the Google Cloud Console, and you can see there's the newly created service. You can see that this service is front-ending this pod, and you can see that the host name of the load balancer is here, and this is the external endpoint. And if I click on this, it should come up and show me that indeed the application is working. And there you have it. The simplified process is just a few G-Cloud commands to set up and have a fully functional Anthos on AWS cluster. No more Bastion hosts, management service, YAML configuration files, and stuff like that. If you like this video, do me a favor and click on the like button and share it with your friends and colleagues on Twitter or LinkedIn. If you want to see more technical videos from ROI Training, you can peruse our YouTube channel, and you can subscribe to the channel to get notified for newly posted videos. Thanks very much.